Hello students, I hope you had a great weekend. This is the document for 3.5 Introduction to Factoring. So if I were you, I would have this video pulled up and then be taking notes on this document as the video is going. There will be times where I prompt you to pause the video and try some problems yourself, and then you can come back to the video to see if you got them right. And then when you are done watching the whole video, done filling out the whole document, go into the Microsoft form and input your answers that you got on certain sections, and I'll tell you what those are. All right, so let's get started. So the last couple weeks we've been talking about key characteristics of quadratic functions, and one of those key characteristics is roots of a function. Remember, roots are where our graph crosses or touches the x-axis. So just as a reminder, let's look at A and B graph here. And these are two answers that you will put in a Microsoft form. So what are the roots of these functions? Pause the video, see if you can figure out the roots for A and B, and then come back to the video and see if you got the answer right. Okay, hopefully you were able to get these right, but let's see what the answers are. For graph A, and you can circle these if you want to help you, we're looking for where does our black curve cross the x-axis. Our x-axis is the horizontal number line on our coordinate plane. And so this crosses at x equals -4 and x equals 0. Okay, so those would be the two roots, and hopefully you were able to get that right. For graph B, we have this blue curve, and it's crossing at x equals -2 and x equals 1. If you're still having trouble figuring out the roots from the graph, please let me know and we can work on that together this week. So today we're going to actually move from getting the roots from the graph to getting the roots just by looking at a function in function notation. So first, to build up to that, let's throw it all the way back to mystery numbers, all the way back to the first month of school when we were solving equations. And I would say something like 4 times what number equals 0. That's what this equation right here represents. For x equals 0, 4 times some number equals 0. So what does x have to equal in order for this to be true? What is that mystery number? And you might be saying in your head, x has to equal 0. There's no other number that I can multiply by 4 so that my end result is 0. All right, example number 2. I might say something like x plus 5 equals 0. If x plus 5 equals 0, what does x have to equal? X has to equal -5. So what can I add to 5 so that I end up with 0 as my result? The only thing that's going to be is -5. A negative number and its same positive are going to cancel each other out. Example number 3. I know this is not how we normally write our equations. We usually put the x after our number or our coefficient, but this is a way we could write it. So instead of saying 4x, we said, or 4 times x, we said x times 9. What does x have to equal? X would have to equal 0. Okay, example number 4. X times y equals 0, or xy equals 0. Now, we don't know what x or y equal. These are both mystery numbers to us. But what we can say is what would make this true. What times what equals 0? So the only way you multiply and you get 0 is to multiply by 0. And so either x has to be equal to 0 or y has to be equal to 0. X could be 100, as long as y is 0, then they're going to multiply to get 0. Or y could be -5, but as long as x is 0, they would multiply together to get 0. So either one or the other has to be equal to 0. So let's keep going with that idea. On example number 5, we actually have a term being multiplied by what we call a binomial, so two terms together. So we have x and x minus 2, x times x minus 2. So if we think about these as two separate pieces, again, we don't know, there's a mystery number in both of them, but either x can be 0, so that these two pieces multiply together to get 0, or x minus 2 could be 0. So we take these two pieces, we say either one of them is equal to 0 or the other is equal to 0. So either x equals 0, just this piece, or x minus 2 equals 0. Well, what minus 2 equals 0? We can add 2 to both sides, or we can just know in our head what minus 2 equals 0. So that's going to be x equals 2. Okay, so we're building up to this. So this is what we just did actually in example number 5, is get some roots from a quadratic function. And so when factoring quadratic functions, there will always be exactly 2 roots. And remember, those are our x values where it crosses the x-axis, even if the 2 roots are the same number. So we talked about last week in our notes how you might have a graph that goes up and all the way back, goes down and all the way back up, and so it crosses over twice. Those would be roots with 2 totally different numbers. Or you could have something like this, where it just goes and touches it, but we still, when we solve it, it's gonna look like 2 roots. It's just gonna be that number twice. And so let's look at that. Example number 6, we have x minus 2 and x minus 2 equals 0. So these are being multiplied together. These are 2 different pieces. Okay, so we've got to figure out which of these, what will they equal, so that when we multiply them together, we are going to get 0. So either x minus 2 equals 0, or x minus 2 equals 0. Okay, same thing up here. Remember, either x had to be equal to 0 or y had to be equal to 0, even though we're putting something in that's like a longer equation or longer expression, that's okay. So x minus 2 equals 0. What is going to make that true? What number minus 2 equals 0? That's going to be 2. Again, what number minus 2 equals 0? That's going to be 2. So we'll still say x equals 2 and x equals 2. Even though it seems repetitive, we still have 2 values, 2 different ways, 2 different roots, even though they're the same number. All right, example number 7, we have that same idea, except this time we're going to have 2 different numbers. So we have x minus 2, this piece, being multiplied times x plus 3. Again, the only way for this to be true, for these 2 pieces to multiply together to get 0, is for one of them to equal 0. So what does x have to equal so that x minus 2 equals 0? And then what does x have to equal so x plus 3 equals 0? Well, if we solve this one, we can add 2 to both sides. We get x equals positive 2. If we solve this one, we can subtract 3 from both sides. We get x equals negative 3. So our answers are x equals 2 and x equals negative 3. And you don't have to do all this solving stuff right here. If you can say in your head, okay, what minus 2 equals 0, what plus 3 equals 0. All right, so the first thing I want you to do, you have 5 of these that I just did. I want you to practice with these 5. Pause the video, get your answers. These are 5 that you will put on your Microsoft form, so you can do that now, or you can do it after you're done with the whole video and document. But pause the video and do these now. Okay. Okay, hopefully you paused and now you're back. I'm not going to give you the answers to these because I want to see how you did on the Microsoft form. So again, remember to go back at some point and put in your answers on that Microsoft form. All right, so these are all quadratic functions where we were able to look at a function in function notation and get the roots from the function instead of the roots from the graph. And so whatever you got for a root here, if you actually went and graphed this, and you can check this out, go type this into Desmos, and your graph will, if you got your roots right, your graph will cross the x-axis at those places. So for the problems above, you were given the factored form of the function. So let's look again at example number 5 from over here. Example number 5 said x times x minus 2 equals 0. And so this is the factored form. This is a factored form. You have two things being multiplied by each other. Factored form means two terms being multiplied. Okay, so what would the unfactored form look like? The unfactored form means that we go from this to something that looks more like the standard forms of functions that we looked at last week. And so the way that we're going to do that is we're going to distribute, multiply this out. So we end up with x times x is x squared, and x times negative 2 is negative 2x. This is still equals 0. So this would be called the unfactored form, and this goes here. This was the factored form. This is the unfactored form. So let's take a look at another example. We're gonna take this factored form, which is two pieces being multiplied together, and then we're gonna get it to our unfactored form. So we've got to distribute x times x equals x squared. X times 3 is 3x. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And this is all still equal to 0. Then we need to put things together that are alike. So if we have 3x and negative 2x, we end up with 3 minus 2 is just going to be 1. So x squared plus 1x minus 6 equals 0. And that is the complete unfactored form, or I told you last week that this is the standard form. Okay, so factored form means you have two pieces being multiplied together, and then unfactored form means you just have the whole function being written out in individual terms. This is called this standard form. Okay, so recap. We can look at a factored form. As long as we have it in factored form, we can get the roots of the function. We can go from factored form to unfactored form by distributing, and now we'll go from factored form. We can go from factored form to standard form. Now we're going to go from standard form to factored form. So I'm going to teach you two different ways that we can do go from standard form to factored form. So the first one is called the box method. This is my favorite way of doing, and this is what we call factoring. We go from unfactored form to factored form. This is factoring. So with the function in standard form, unfactored form, we have x squared plus 4x plus 4 equals 0. So This is what's called the box method, and then we will talk about the list method in just a second. You can choose whichever method you prefer. So the box method tells us we're gonna break this up into these different boxes. We have 3 pieces and we have 4 spaces. So we're gonna break this up into these 4 spaces. I'm so sorry, my cat just knocked something over. I apologize for that. So the first term is the x squared term is always gonna go in our first box. The last piece is always gonna go in our last box. Then we've got to figure out some number that multiplies to get 4, multiplies to get our last number, and adds together to get our middle number. So we can first make a list of numbers that multiply to get positive 4. What numbers multiply together to get positive 4? Well, that's going to be 1, 4, and 2, 2. And we won't think about negative numbers right now, but that is all of the numbers that two numbers that multiply together to get 4. So 1 and 4 and 2 and 2. Then we ask ourselves, which of these pairs add to get this middle number? Okay, so again, we want a number that multiplies together to get our last number and adds, we want 2 numbers that multiply together to get our last number and add together to get our middle number. So which of these add together to get 4, 2, and 2? 2 times 2 is 4, 2 plus 2 is 4. And so that is how we're gonna fill in our last 2 boxes. We have 1 term left here, but we need to split it into 2 places. We do that by saying, all right, instead of 4x, now we're gonna have 2x and 2x. Now, doing what we just did, this helps us get what our 2 factored pieces should be. So on each side of this box, we're gonna have x and x. That's what multiplies to get x squared. X times x equals x squared every time, or equals x times x like this. And then finally, we take this number that we split up, and that's what's gonna multiply to get this. So 2 times 2 should multiply to get 4. It does. So we take these 2 pieces from our box, x plus 2 times x plus 2. Now we went from standard form to factored form. From here now, we can do like we did in our first few examples, we can actually get the roots. So we end up with x equals -2 or x equals -2. Those are the roots of these 2. What are our roots? Again, back to these examples. Same thing here. We want to figure out what multiplies together to get 0, and that will be where our graph crosses the x-axis. So let's do another example. Another box method example. So I'm going to draw our box. Again, my first term, my x squared, is always going to go in my first box. My last term, just the whole number, is going to go in my last box. Then I've got to figure out, how do I split up 3x to go into these 2 boxes? So these, the 3x is going to split up into these 2 boxes. So first I need to make a list of numbers that multiply together to get 2. What 2 numbers multiply together to get 2? That's going to be 1 and 2. Is there anything else that multiplies together to get 2 as far as positive numbers? No. So then we ask ourselves, is 1 plus 2 equal to 3? It is. So this is going to be our pair of numbers that we're going to use. So 3x gets split into 1x goes here and 2x goes here. So we're splitting that whole 3x into two pieces, 1x and 2x. So again, now we want to figure out, this is a box with some area. Now we've got to figure out the dimensions of that. So it's always going to be x and x, because x times x equals x squared. And then whatever numbers we have here will easily go on the outside of our box. So for this part, we have plus 2 and plus 1. Then we're able to take those two pieces and multiply them together. And if we distributed these back out, we would end up with our unfactored form. So this is x equals -2 and x equals -1. All right, again, this is the box method. You do not have to use the box method to factor. But if you like the box method, then use it. If you like the list method better, use that. So let's look at the list method. The list method is related to the box method. It's just we're gonna write it a little bit different way. So I actually put the exact same problems for our examples here, so we can see they will get the exact same answers. So with the list method, we're gonna start with parentheses equals 0. When we have a quadratic that we're factoring, we're always starting with x squared. And so we know our factored form, look, both of these start with two terms and they both start with x. So we know that our first part is gonna be x. Then we've got to figure out what these numbers are for our factored form. And so we're going to make our list. We're going to take our last number and make our list. What pairs of numbers multiply together to get 4? That's all we got to think about right now. So that's 1 times 4 and 2 times 2. Then we look at these, so this is multiply times 4. Now we look at these and we say, okay, which of these pairs that we figured out multiply times 4 add to get 4? And that is going to be 2 and 2. So we put one number there and one number there, and we have our factored form. Then from here, we say, all right, if this piece was equal to 0, that would mean x has to equal 2. -2. If this piece was equal to 0, we'd have to also have -2. So those are our roots. So again, we're going from our standard unfactored form to our factored form. These are two things that would multiply together to get this function. And then from our factored form, we're able to get our roots. And this is where our graph would cross or touch the x-axis. So we never want to forget what our whole goal is here. All right, let's do one more list method. We're going to make our parentheses equal 0. Both of them are always going to start with x and x, as long as our coefficient of a quadratic is 1. So we only have one x squared. This is like an imaginary 1 right there. So that's going to start with x and x. Then we go make our list. What pairs of numbers multiply to get 2? That's going to be 1 and 2. Are there any other numbers that multiply to get 2? Pairs of numbers? Well, also -1 and -2, and we'll start looking more at negative numbers tomorrow. But for our purposes, which of these add to get a +3? Which of these add to get a +3? Well, that's going to be +1 and +2. So one number goes in one parentheses, one number goes in the other. 1 times 2 is 2. 1 plus 2 is 3. So we have exactly what we need. Now our factors of this is if this piece is equal to 0, x plus 1 equals 0. What does x have to equal? X has to equal -1. If this piece is equal to 0, x plus 2 equals 0, that means x has to equal -2. So again, we got these are the exact same functions. Example number 1, example number 1. We ended up with the exact same factored form and the exact same roots. These are the standard form. We got to the factored form. Even though we wrote it in a different order, it's still the same. We got the same roots. So you can use whatever method that you prefer. You can go back and forth between them, use the box method sometimes, use the list method sometimes. It's totally up to you. Okay, so now the video is almost over. What I want you to do, and you can do this on your own paper, work out these 6, 7, 8, 9, and 10 individual practice, factoring. Your final answer should be your roots. So you'll get to your factored form and then write out your roots and then go into the Microsoft form and put in those answers. All right, everyone, if you have any questions, please let me know. Remember that I'll have tutoring hours tomorrow, and I'll be checking in with you about your understanding. So have a great Monday. And again, let me know if you have any questions.